Okay, gentlemen, today we're going to review a little bit what you should know already. Very simple stuff. You should know what these terms mean. You should know what volts mean, okay? You should know what amps mean. And you should know what ohms mean. One thing that you may not know yet is a fourth one called wattage. Now, if you notice, if you have a blow dryer, it'll be in wattage. If you have a microwave, there'll be a wattage on it. If you have on the name tag, you have a coffee pot, be in wattage. So just like volts is a measurement of electrical pressure, it's like amps is a measurement of the flow of, okay, volts is a measurement of electrical pressure. Amps is a measurement of electricity flowing, okay? Current flow, electron flow. Ohms is a measurement of a resistance to that flow. You guys should have all that down already. We've been going over it for a bit. Wattage is a measurement also. All four of these things are measurements, okay? You're measuring pressure, electrical pressure. You're measuring electrical flow. You're measuring the resistance to electrical flow. Here we are measuring power. And just like this is voltage and we shortened it, amperage, we shortened it. You know, voltage is, we're calling it volts, amperage, we're calling amps. There's no such thing as ohmage, but ohms is already fixed for us. Don't have to fix it. Let's fix this one, okay? Normally, people don't get all fancy talking about wattage. They will use the word watts, okay? So watts is a measurement of power. So how do they start? I mean, you got to think, remember we talked about amps is like 1 coulomb of electrons past a point in 1 second, you know, so somebody somewhere had to figure out a standard so they could measure. So watts actually ties into horsepower. So you can figure they probably come up with this formula a long time ago when they just had horses. So 1 horsepower equals 746 watts, okay? So we've already used Ohm's law to find out, like if we don't know like one of these three, we can figure out, if we know 2 of them, we can figure out the third one. For instance, like if you multiply your ohms times your amps, that's going to equal your volts. So in this case, if we want to find watts, we want to find out how much power something is. If we know the voltage and if we know the amperage, we can figure that out. So like a hair dryer, you know, like maybe 800, 1,000 watts. Microwaves, maybe 1,200, 1,500 watts. So if you look on like the name tags and stuff, everything, most everything that draws a considerable amount of power, they'll have it listed in watts. On motors, they list it in horsepower. So, if you know something is, you know, if a motor is 2 horsepower, then you can figure out how many watts it is. It would be 1,492 watts, I would guess, if I did my math in my head right. So, but mainly for small electrical appliances at your house, like a hair dryer, microwave, coffee pot, just whatever. Even your light bulbs, they're measured in watts. So we know that volts times amps equals watts. Okay? So we can use that. Now, for when we use just these three, we can actually troubleshoot circuits and figure out, what's wrong, because all of this is going to be, I mean, if you know your amps and your ohms, you can figure out what the volts are. Watts, you can figure out what they should be, not necessarily what they are, because you could have a 100-watt light bulb and you could do the calculations, and that light bulb may not, if your voltage is low or there's some other resistance in there, your light bulb may not be making 100 watts of power. So this will tell you what you should have the power you should have when everything's working perfect. It's not a good way to troubleshoot stuff. To troubleshoot stuff, you want to use these top three, okay? Watts will give you an idea. Now you can backtrack, like let's say you knew the watts, okay? And maybe you knew the volts and you knew the amps. You can figure this out like, well, actually, if you knew the watts and you knew the volts, then you could figure out what it should be. And like, then you could check your amps or check your own, figure out what the resistance. You could backtrack and figure what stuff should be. And we'll kind of show you how to do that. We will show you how to do that. Anyway, so again, a circuit requires three things. It requires a power source. We're going to use a symbol for a battery here. Okay. So it requires a power source, number one. Number two, it requires some sort of a conductors. And number three, it requires some sort of a load. So there's a load, that's a symbol for a resistor. So again, you guys should know, using Ohm's law, if you know two of these values, if you know, let's say you know that your resistance is 10 ohms, okay? And you know that your amperage is 15 amps, then you should, by using Ohm's law, you should know what that voltage is. So again, I'm trying to get you guys away from the algebra stuff. Now, if you're really good at math and really good at algebra, fantastic. Go ahead and use it because you can go on further. But just for your basic stuff, the thing I showed you yesterday with the circle, that's really all you're going to need. You know, if you don't want to be an electrical engineer and you just want to be a basic electrician, you're not going to need to know a whole lot more than this. I'm going to give you something else that might help you. But so anyway, we put our volts on top, put our amps here, and our ohms here. And then you can figure out what that is just by plugging in the numbers. It's just that simple. So we don't know what our voltage is. We have no idea what this is, okay? But we have the other two. So we have 15 amps and we got 10 ohms. So if you multiply those straight across like you know to do, let me turn off some lights here, make this better. That better? That's going to give you 15 times 10 is going to be 150 volts. So you know this is 150 volts. Problem solved. That easy. You don't have to know any algebra. So in this case, let's say we don't know our amperage, all right? And let's say we know our voltage. Let's say it's 25 volts. So we go over here, plug our numbers in, all right? We know we got 25 volts on top. And we got 10 ohms right here. We don't know our amperage. That one's missing right here. Okay, so with 10, we divide that into 25, and it'll go 2.5 times. So, all right, we would have 2.5 amps. Just that simple. Easy, easy, easy. So this would be 2.5. All right. Now, let's say we don't know our ohms. So we got 25 volts, 5 amps, and we do not know our ohms. So I'm just plugging these numbers in. I don't know the answers ahead of time, but I'm trying to keep them easy. So we know we got 25 volts. We know we got 5 amps. So 5 into 25. Excuse me for a minute. Thank you. So 5 into 25. 25 divided by 5 is going to be 5. So we have 5 ohms down here, okay? So that should be very simple. I just went through Ohm's law with you, so you can figure voltage, amperage, and ohms, as long as you know the other two. We did 3 examples right there. So I'm probably gonna make your test like a little video for you guys, and I'll be putting this stuff on the board and you can answer it that way. So, but right now I'm just recording this last one so you can go back and look at it. Anybody who missed this class or is sick or whatever, can go back. So now, watts. Let's play around with watts a little bit, all right? So let's say we got a 60 watt light bulb in here, okay? Draw a little light bulb. I mean, most of you guys have a 60 watt light bulb at home, okay? We're talking about the old incandescent, not the new LED stuff. But 60 watts, remember, is a measurement of power. So in a perfect world, at the right voltage, and nothing else is wrong with the circuit, it doesn't have extra resistance in it, this is going to be making 60 watts of power, okay? So remember, watts is a unit of power, of horsepower. 746 watts equals 1 horsepower. In other words, if this light bulb was 746 watts, it would take 1 horse to make it work right. And I think, if I remember right, 1 horsepower equals a horse able to pick up 33,000 pounds, 1 foot in 1 minute. So anyway, give you an idea how powerful electricity is. I mean, like if you had a 1,000 watt light bulb, okay, it would take a little bit more than 1 horse to make that work. That horse working his poor little butt off, making that light bulb stay lit. But let's play around with this a little bit. Now, so we got 60 watts, all right? And let's say we have 30 volts. So if we have 30 volts and 60 watts, we know that volts times amps equals watts. So what we can do, give me some room here. We know our voltage, so we could do 30 here, right? 30 volts times, we don't know our amps. That is an unknown. We don't know our amps, but we know that is supposed to make 60 watts, right? So 30 volts times something is going to equal 60 watts. So obviously, like in algebra, to solve for this, what we're going to do is we are going to, divide this by 30. This crosses that out, divide both sides of your equation by 30. And so 30 will go into 60 2 times. So basically, that's going to equal 2 amps. So we can use this. Now I'm going to show you something right here if you want. I'll show it to you right now. So what we can do, instead of, if you're not good with math, then you can make your own little circle. You can make a circle that looks like this. So this would be your Ohm's law. You can also make one, and this will be for power, or we can pull it for watts, okay? We can make one for watts. Now, what we'll do is we'll put your watts up top, okay? And we know that volts, according to this, right here, volts times amps equals watts. So we'll make another one of these. We'll go volts times amps equals watts. So let's see if our little circle works. So we know this is 30 volts. So we'll put 30 in here. And then we don't know our amps, but we do know our watts is going to be 60. So we divide 30 into 60, and guess what? Look, we got 2. It works. So now we know we have 2 amps. So let's see if it works the other way. Let's say we didn't know this one. So 2 into 60 going to be 30, right? It works. We didn't know this one. 2 times 30 equals 60. So 2 amps times 30 volts equals 60 watts. 60 watts divided by 2 amps equals 30 volts. 60 watts divided by 30 volts equals 2 amps. So this little tool here will keep you from the algebra. You can just use this for your watts. Now remember, this is only going to work when everything's working like it's supposed to. Like a 60-watt light bulb is designed to make 60 watts worth of power. But at a certain voltage and with no additional resistance in the circuit, it will make the 60 watts. But if you got a little problem somewhere, it's not going to. And you really don't have a watt meter, most electricians anyway, don't have a watt meter that can check and see if something's actually making 60 watts. So this is just good. So you know how much power is something is putting out. This is really better for more for troubleshooting stuff or designing a circuit. This is for designing a circuit too, but it's not so good for troubleshooting. Now, so we'll get rid of all this since we're going to use that instead. So we don't have to do that algebra stuff. We'll just use a little circle like this with watts on top and volts times amps on the bottom. And then this whole thing will work the same for watts. Now, interesting thing is there's something missing here that we don't have. So we started out, remember we didn't know that, but we knew we had 60 watts was on top. 60 was on top. And we put our 30 volts here, divided 30 into 60, we got 2 amps. We know we have 2 amps. Now that we know we have 2 amps, we can figure out what the resistance of this light bulb should be. Because we could use our Ohm's law over there, and we could put our 30 volts on top, right? And there's our 2 amps right here. So we got 2 amps. So 2 into 30, or 30 divided by 2, is going to equal 15 ohms. So now we know our light bulb is 15 ohms. So now you've got these 4 things that you can utilize. And to tell you the truth, unless you're going to be a super duper electrical engineer, or you're going to be designing stuff, to be a basic electrician, these 4 things is really all you need to know. Volts, amps, ohms, and watts. That's all you need to know. And granted, you start getting deeper into stuff, into induction and capacitance and stuff. Everything is going electronic nowadays. And hey, the more you know, the better you're going to be. So like I'm saying, this will get your foot in the door, and you can do a lot with this. You could probably survive your whole electrical career just knowing this. And then you can have the really smart guys, take care of the other stuff. But if you can do the other stuff, do it. Know about inductance, know about power factor, know about capacitance. I mean, all that stuff is good. And shoot, with in the old days, they used to have to take an alternator or spin an alternator to make alternating current out of direct current. And for you to change sine waves and voltages, you needed to just like spin stuff and have motors and windings and everything. And nowadays it's all done electronically, and you get these square waves and real sine waves and square. I mean, we won't go into all that right now. Anyway, long story short, boom, there it is. Ohm's law works like a charm. You can do the same thing with your watts. And then right here, if you have these watts, then you can figure out your amps, and then you can figure out your ohms. So you can figure out anything you want with these 4 things right here. So gentlemen, I'm going to leave you there. And I mean, that should be good. We will talk to you later.